Today we're going to do section 9.1, significance test, the basics. According to an article in the San Gabriel Valley Tribune, most people are kissing the right way. That is, according to the study, the majority of couples tilt their heads to the right when kissing. In the study, a researcher observed 124 couples kissing in various public places and found that 83 out of 124 of the couples tilted to the right when kissing. That's a p-hat of 0.669. Is this convincing evidence that the true proportion p of all couples that kiss the right way is greater than 0.5? Give two explanations for why the sample proportion was above 0.5. Okay? First explanation, people really do prefer the right over the left. Okay? What's another explanation? There's no preference. People don't have a preference right over left. We just happen to get one that high by sampling variability. Okay? How can we decide which of the two explanations is more plausible? That's asking, if there is no preference, how likely is it to get a sample proportion of 0.669 by chance alone? To answer that question, we do a significance test. Okay? So what is the basic idea of a significance test? The basic idea. A claim is made about the value of a population parameter. In this case, the population proportion of all couples that kiss the right way. When a statistic from a sample suggests the claim isn't true, we must decide which explanation is more plausible. 1, the claim is true and the statistic is different because of sampling variability. Or 2, the claim isn't true at all. If the value of the statistic is so different it would rarely occur if the claim is true, you have good evidence the claim isn't true. Okay? These claims that we're talking about are called hypotheses. So let's look at hypotheses. We have two types of hypotheses, null and alternative. We're going to look at the null first. The null hypothesis is denoted by H sub O. Okay? It's a statement of no difference, meaning there's no preference, there's no difference. It's always equal. The null hypothesis always has an equal sign. The alternative hypothesis is represented as H sub A, and it is what we're trying to find evidence for. We're always trying to find evidence for the alternative. We're always trying to prove that the null is not true. Okay? When we do these, when we write our null and alternative, we always use the parameter, not statistic. So we're going to use p or mu, not p-hat or x-bar. Okay? Alternative hypotheses can be one-sided or two-sided. One-sided is either greater than or less than. Two-sided means not equals. So if you're looking at trying to determine whether it's one-sided or two-sided, then look at the words they give you. Do the words they give you lead you to believe greater than or less than? Or do they give you the words changed or different? Changed from this or different from this? That would lead you to believe it's a two-sided hypothesis. Okay? So let's look at an example. Describe the parameter of interest in kissing the right way. All right, P equals the true proportion of couples that kiss the right way. State the hypotheses for performing a significance test. Give me the null hypothesis and the alternative hypothesis. All right, well, let's go back and read the question again. Is this convincing evidence that the true proportion P of all couples that kiss the right way is greater than 0.5? So my null, my H sub O, is P equals 0.5. It has to have an equal sign. My alternative, my H sub A, is P is greater because that's what it says, greater than 0.5. Okay, let's look at another example. Mike is an avid golfer who would like to improve his play. A friend suggests getting new clubs and lets Mike try out his 7-iron. Based on years of experience, Mike has established that the mean distance the balls travel when hit with his old 7-iron is mu equals 175 yards, with a standard deviation of sigma equals 15 yards. He is hoping that this new club will make his shot to the 7-iron more consistent, less variable, and so he goes to the driving range and hits 50 shots with the new 7-iron. Describe the parameter of interest in this setting. Well, he's talking about his variability, so that would be standard deviation. Okay, so we're talking about sigma equals this true standard deviation of the distance he hits the ball using the new 7-iron. All right, state the appropriate hypotheses for performing a significance test. All right, H sub O. Sigma equals 15 because that's where he started. H sub A, sigma is less than 15 because he wants less variability. All right? All right, when performing the significance test, we state the hypotheses. Then, along the way, we calculate our p-values. So what's a p-value? A p-value is the probability that measures the strength of evidence against the null. against the null in favor of the alternative. Okay? If the p-value is small, we have good evidence against the null. If the p-value is large, it is possible the null is true, and we got a statistic this extreme by chance alone. Okay? Here's how we interpret the p-value. Write it down exactly this way. You don't want to use creative writing on this. You want to interpret it exactly this way. Assuming blank is true, that's your H sub O, there is a p-value probability of getting a sample blank of blank by chance alone. Okay? Assuming your null is true, there is a p-value probability of getting a sample blank of blank by chance alone. All right, let's do an example. In the kissing example, where your p hat was equal to 0.669, the p-value was 0.0008. Interpret this value. So, assuming p equals 0.5 is true, there is a 0.0008 probability of getting a sample proportion of 0.669 by chance alone. All we did was fill in the blanks. Okay? Do the data provide convincing evidence against the null hypothesis? Explain. Remember, if the p-value is small, we have good evidence against the null. In this case, our p-value is really small, so we have good evidence. Yes, since the p-value is very small, random chance is not a plausible explanation. There is convincing evidence that the true proportion of people kissing the right way is greater than 0.5. Okay? All right, so for the conclusion of a significance test, there's two possible outcomes that we can have for a significance test. Okay? First outcome is we reject the null. There is sufficient evidence for the alternative. So the first case, we reject the null. Second case, we fail to reject the null. There is not sufficient evidence for the alternative. So we either reject it, there's sufficient evidence for the alternative, or we fail to reject it, there's not sufficient evidence for the alternative. Okay? We never say H sub O is true. All right? We never, ever, 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 ever want to say H sub O is true because we never know that. All right? It's like when people go to court and there's a trial, you're innocent until proven guilty. You're not found innocent or guilty. You're found not guilty or guilty. We never want to say that the null is true. We never want to say you're innocent. We just say you're not guilty because we don't know the innocent part for sure. We don't know the null is true for sure. Okay? What must be included in your conclusion? Your conclusion must include the three following things. First, an explicit comparison of p-value to a stated significance level. Okay? 2, a decision regarding H sub O. You either reject it or you fail to reject it. And 3, evidence for or against H sub A in context. All right? So what is the significance level? Significance level is a fixed level, and we call it alpha. It's the Greek letter A, alpha. Okay? Results are statistically significant when your p-value is less than alpha. All right? So let's look at an example. For his second semester project in AP Statistics, Wes decided to investigate whether students at his school prefer name brand potato chips or generic potato chips. He randomly selected 50 students and had each student try both types of chips in random order. Overall, 34 of the 50 students preferred the name brand chips. Wes performed a significance test using the hypothesis H sub O p equals 0.5 versus H sub A p is greater than 0.5, where p equals the true proportion of students at his school who prefer name brand chips. The resulting p-value was 0.0055. What conclusion would you make at each of the following significance levels? Okay, well here we go. At 0.01, my p-value is less than my alpha. That's what I say. Since the p-value is 0.0055 is less than alpha equals 0.01, there's my explicit comparison of p-value to stated significance level. We reject H sub O. There's my decision regarding H sub O. Then here's my evidence. There is convincing evidence that students at Wes's school prefer name brand chips. That's how you conclude. All right, let's look at the next one. Alpha equals 0.001. This time, my p-value is greater than my alpha. Since the p-value 0.0055 is greater than alpha equals 0.001, we fail to reject H sub O. There is not convincing evidence the students at Wesley School prefer name brand chips. Okay? All right. When performing significance tests, there are two types of errors we can make. A type 1 error says we reject H sub O when H sub O is true. We reject the null when we shouldn't have. Okay? And the probability of doing that is alpha. The probability of making a type 1 error is your significance level alpha. All right? What's a type 2 error? Failed to reject H sub O when H sub O is true. So type 1, reject H sub O when H sub O is true. Type 2, fail to reject H sub O when H sub A is true. Okay? We failed to reject H sub O when we should have. Alright? So let's look at the table. Across the top we have truth about the population, and on the side we have decision based on the sample. If we reject H sub O when H sub O is true, in this first square right here, if we reject H sub O when H sub O is true, we have committed a type 1 error. Go right next to it. We reject H sub O when H sub O is false. That means we made the correct conclusion. On the bottom left, we fail to reject H sub O and H sub O is true. That means we made the correct conclusion. And in the bottom right, we fail to reject H sub O and H sub O is false. We have committed a type 2 error. Okay? All right. So let's look at a couple of examples of what these look like in real life situations. Okay? All right, in the first example, in a criminal trial, a defendant is presumed innocent until proven guilty. Therefore, our null hypothesis is the defendant is innocent. What is the alternative hypothesis? The alternative hypothesis is the defendant is guilty. Describe a type 1 and type 2 error and explain the consequences of each. All right, type 1 error. You reject H sub O when H sub O is true. So the defendant is innocent but found guilty. You reject H sub O when H sub O is true. H sub O is our null hypothesis, is defendant is innocent, but you find him guilty. That's the type 1 error. So what's the consequence? An innocent person goes to jail. Okay? A type 2 error. Type 2 error says you fail to reject H sub O when H sub A is true. So defendant is guilty, but found not guilty. What's the consequence of that? A guilty person goes free. Okay? Let's look at another example. If you wanted to go skydiving, you would assume that you have a working parachute. Therefore, our null hypothesis is that the parachute works. What is the alternative hypothesis? Parachute doesn't work. Okay? Describe a type 1 and type 2 error and explain the consequences of each. Type 1 error. You reject H sub O when H sub O is true. So you reject a working parachute. Okay? So what could happen? You just lose money for the trip, right? You paid money to go skydiving. You say, hey, I don't want this, even though it was working, so you don't skydive, and so you paid money for nothing. That's a consequence. All right? Type 2 error. Type 2 error says you fail to reject H sub O when H sub A is true, so you fail to give up your bad parachute, so you keep a bad parachute. What's the consequence of that? Well, you probably die from it, right? So bad consequence. All right? So that's the basics of significance tests.